An emergency shutdown system, or ESDS, is designed to minimize the consequences of emergency situations related to the escape of hydrocarbons or outbreak of fire in hydrocarbon-carrying areas or areas which may otherwise be hazardous. The ESD system is tested prior to transfer operations. In LNG operations, the terminal and the ship agree on how many tests will be done, and who will trigger the shutdown testing before the arms are cooled. This is called an ESD warm test. Testing done after the arms are cooled is called an ESD cold test. During the transfer of liquid, a series of key valves connect the supply tank, with the discharge pump, to the receiving tank. The emergency shutdown system is an emergency control system used to electronically connect the ships in the terminal's transfer systems, and manage the start and stop sequences of a plant or machine. Sudden pressure increases, or surges, are an undesirable condition in liquid transfer. Pressure surges can cause pipeline ruptures. The ESD system stops the transfer pumps and closes the main valves with the particular sequence and timing. The discharge pump and the discharge valve on the pump are stopped and closed by the computer. The supply tank valve is closed, in its timing and sequence, by the computer. The jetty valve is closed, in its timing and sequence, by the computer. The loading M valve is closed, in its timing and sequence, by the computer. The ship's manifold valve is closed, in its timing and sequence, by the computer. The ship's mainline valve is closed, in its timing and sequence, by the computer. The ship's tank valve is closed, in its timing and sequence, by the computer. The timed closure of the other valves is to facilitate the release of the powered emergency release coupling. The powered emergency release coupling has the ability to actively and remotely release the coupling without strain on the transfer system. The ESD shuts off transfer flow, the valves close, and the emergency release coupling separates.